Hello students, in this video we are going to demonstrate the experiment number 5, that is rapid advanced circuit. First I'll give you background of the circuit before starting the simulation. In this circuit, generally see there is a hydraulic cylinder. The speed can be changed using the throttle valve. By adjusting the throttle valve or flow control valve, different speed or different velocity can be achieved of the hydraulic cylinder, right? But here the thing is that for example drilling application, in single, for example in single axis or single movement, for example forward movement, in forward movement only two different speeds are required. Example, say drilling machines. In drilling machine there is a tool bit, so tool bit uh, should reach the workpiece uh, at higher speed. If you make it slow, what happens? The total the machining cycle time will increases. So tool bit should reach the workpiece at a higher speed in order to reduce the total cycle time. But when it is doing the metal cutting operation, the speed of the tool which is moving, which is advancing in the drilling process or cutting process, that we call as a feed rate. So feed rate has to be very low. So the speed has to be, or velocity of the cylinder should be less. So how that means in single direction, that is forward movement or downward movement, tool advancement is faster, but when tool is doing the cutting operation, its movement should be slow. So we want to have a rapid speed as well as the slow or creep speed, or we can also call as a feed speed. That should is low speed is required. And after doing the drilling, complete drilling, so tool bit return to the home position should be at a higher speed in order to reduce the total cycle time, right? So here the requirement is there is a hydraulic cylinder. Say for example upward movement is taken here. There is sensor B1 and B2. So cylinder should reach B1 sensor at a faster rate. From B1 onwards it should go with a slow speed. From B1 to B2 slow speed. Assume that B2 is placed at the end of the stroke. So B2 gives a signal for process is completed, so that cylinder can go back. That is retraction movement is initiated by the B2 sensor. So B1 sensor is the one which changes from high speed to low speed. That gives a signal for low speed. Okay, so the entire process is like by operating a switch, cylinder should move upward till B1 high speed. From B1 it is low speed till B2. When it reaches B2, automatically it should retract and comes to home position. So this kind of movement is required. The one such application I already given, that is drilling machine application. Two different speeds are required in single direction. Okay, so that is what I'm going to demonstrate now. So this is a hydraulic circuit, this is an electrical circuit designed. So now the same circuit we want to simulate it in the software and validate this designed electrical circuit is suitable for the required moment, right? That is what we are going to do it now. And here to change this free from change the velocity from high velocity to low velocity, to switch between high speed and low speed, there is a 4x2 direction control valve we are using. Actually 3x2 valve is enough, but 3x2 valve is not available in the laboratory, so we are using 4x2 as a 3x2 valve by blocking the B port. Okay, and the double acting cylinder movement is controlled by 4x3 direction control valve, which is having two solenoids called Y1 and Y2. If Y1 is on, cylinder will move upward. If Y2 is on, cylinder will move downward. But why the second direction control is we are using it? That is for changing the speed from high speed to low speed or high velocity to low velocity. And we want two different speed in only one direction. Remember, that is why we are using throttle check valve. Okay, so only one throttle check is throttle check valve is enough, because we are controlling only in upward movement, not the downward movement. So we are using throttle check valve, and pressure relief valve is there, and pressure gauge is there. So let me do this circuit. I will start with the simulation. First, hydraulic circuit will complete. Okay, how it is exactly going on, that is I'll explain using the simulation software. So double click on the software. Yeah, it is quite taking more time. Let me check the internet connection. It is now connected. It's connected. What's the problem? Yeah, now go to new sheet, take a new sheet, and here in the hydraulic section, in the actuator, take the double acting cylinder, and we want it in vertical, so rotate it by 90 degree. I want ports to be on the left side, so right click, mirror it to the vertically. So I want this kind of position. And now uh, there is a 4x3 direction controller. So go to the direction control valve, solenoid operated, and 4x3 direction control valve and tandem center, they are using it. Okay, let us use the same valve. Okay, okay, and we are using the 4x2 valve is also required. So 4x2 solenoid operated, but in the circuit, the 4x2 solenoid valve, see here, here reference position is cross. Okay, so that means we'll take 4x2 valve, this one. This is a 4x2 valve because reference position is cross. Okay, so we have taken two direction control valve, and the circuit quite big, so we have to increase the size of the sheet. Page setup. So let us try this. Working space, I want more. Okay, see here, the A is connected to the piston chamber. A is connected to piston chamber here, and B is connected. So first of all, we want the here important valve is like flow control valve, which is a throttle check valve is required, and direction should be changed. I want check valve in the opposite direction, so rotate by 270. No, sorry, that is rotate by 90 degree. Actually 180 degree is enough. No, from this position rotate 180 degree. So this is the position I wanted, check valve. So the oil which is coming from rod chamber, the oil which is coming from rod chamber will have two possibility. One possibility is, see, first of all, it cannot flow through the check valve. See, its working principle of hydraulics is the amount of oil which is going into the piston chamber, same amount of oil should go out of the rod chamber. So that oil is not able to flow through check valve, so it has to flow through the throttle valve. So that is a restricted flow. Okay, so now here A and P is connected, right? So what I'll do, I'll create another path. That means oil oil from the rod chamber is having two choice now. It can flow through the direction control valve, that is second direction control, 4x2 direction control valve, or it can flow through the throttle valve. Okay, so this is a restricted path. Throttle valve means a restricted path. Free path means it can flow through the 4x2 direction control valve. Okay, so that is how we can create the dependency here. So B, I'll connect it to B here, and this P, I'll connect it to here. That means, see, solenoid Y3 by default it is off. So if solenoid Y3 is off, if solenoid Y3 is off, if solenoid Y3 is off, what happens? There is no flow. There is no flow from P to A. Right? That means blocked position. So oil has to flow through the throttle valve. So that is a restricted flow. That means 1 minute. So that means if solenoid Y3 is off, you can assume that it is slow speed, because oil is forcing to flow through the throttle valve. Throttle valve means you can adjust it low speed or high speed, but we are adjusting always throttle valve position in low opening position, so always low speed. So what you can write it is, when Y3 is off, slow speed, when Y3 is on, high speed. That is what requirement. Other two ports we can block it. So double click on it and then go to the terminator, take the terminator. Okay, 2x2 valve is also enough, but it's not available in the lab, so we are using 4x2 as 2x2 valve. Okay, sorry, yeah, 2x2 valve. Okay, so now P, as usual, P is connected to the pump, that is, and tank, connected to the tank, and a protection circuit as usual, that is pressure relief valve. You have to take it, pressure relief valve, and then connect it here. Okay, so this part is very important, and this and the junction point what we are talking about, this in the laboratory is nothing but a flow distributor. Okay, and we have to take two sensors here, so that is double click on this cylinder. I'm adding two sensors. What is the stroke of the cylinder? See here, maximum stroke here, it is in inch, but change it to mm, 20 centimeter, 200 mm. So now go to the actuating labels. The labels, there are two sensors in the problem. So B1, I'll have say 100 mm. Okay, that is in mm. 1 minute. We'll go to the property here. Maximum stroke is 200. This is 100. This is 100. Now take B2 sensor at 200 mm. 200 mm. Click on OK. Okay, some problem is there in the. Okay, B2 you can take it like 199 because it is not exactly 200 mm. Now it is okay. So B1, B2 sensor is there, right? So now this is solenoid as per the circuit. Yeah, this is a solenoid Y1, y1 means upward moment, y2 means downward moment. Okay, so this is the hydraulic circuit. So there is a space problem, so that is why I am just moving the circuit toward left side. Electrical circuit is quite large. Okay, page, yeah, drawing size is here. Drawing size, I want go to the page. You take the largest size. Yeah, now the size is increased. Okay, it is available in go to page, go to drawing size, and click on the adopt from drawing frame that you just disable it, and then change it to 594 into 841 mm. There's a large sheet. Okay, so there may be okay, now electrical circuit is this electrical circuit. But before starting electrical circuit, I'll open this software once again. I'll copy Control A, Control C, and why? Because it is only for 30 minutes. Go to the sheet, take a new sheet, and go to the page drawing size, disable this one, and then take the larger size. Yeah, and then paste it. Okay, so hydraulic circuit is there. Now electrical circuit is IEC standard, and power supply 24 volts. Okay, and here we'll start with actually S6. I'll tell you what is the significance of S5. That is to reset the entire circuit. So there is a S6 button is the red switch. From there it will start it. So we'll take one S6 push button. S6 push button, and then there is a two normally closed contact is there. I'll tell you why. And then we'll take one relay called K2, and then connect it here. Switch is connected to here. Now I've done the line 2. Line 2 I've done, but line 3 I have to do it. So that is the latching circuit. So that means so here whatever relay name is there, same relay you have to link it here. That is a latching concept. K2. Okay, and this one it is named as S6. You can name whatever you name. S1 also you can name it. Okay, so line number 2, line number 2, line number 3 I've done it. Line number 4 is sensor, that is B1 sensor. B1 sensor is connected to K3 via K4. So B1 sensor is available, the measuring instrument. So the inductive sensor is available. Two inductive sensor is used, positive and negative, that is a power. And output is given to the one more coil called K3, K3, and K3 is given to the sensor not directly, because normally close contact is there, and then just link it to here. Okay, so here it is K4. K4 relay we are not taken, so I cannot link. So K3 should be there. That is a latching concept. So normally open contact. Why this latching is required means, I'll tell you that B1 sensor data can be lost if cylinder rod is not in the position of B1 sensor will be lost. Still we want to have a slow movement, so that in that application it is required. So I'll link it this one to B1. So type B1 here, B1, so it's a sensor, and this one should be normally open. So always latching should be normally open. This is K3. Okay, now one more sensor I'll copy from here. One more sensor is required, and that is also power is required. Okay, and one more relay is required, that is K4. So K4, again K4 is connected through K1 normally close contact. So normally close contact should be used. This is K1. I can link it to K1 because K1 is already available. Okay, sorry, I not taken the K1. So that is, let me take K1 first. That is S5 is connected to K1 in the beginning. That is one more switch. This is actually used for a reset. This is actually used for a reset application. So this is K1. And this is S5. Right, now I can link it to K1. Double click and link it to K1. And latching is required for K4 also. This is K4. Okay, B1, B2 sensor is used. And there is S7 switch. I'll tell you why S7 switch is also used. S7 switch. Sometimes B2 sensor not working. Assume sensor is there but it is not functioning. In that case, cylinder will not able to retract at all. So in that uh, at that time, if you operate S7 directly, it is going to power the K4. So K4 is going to give the power to the retraction. Okay, so that is the redundancy is there. So if sensor is not working, then that is used. Okay, so now in the line number 2 of K4 and K1 we have to link it. This is K4 and this is K1. And this one in line number 5 also K4 is there. This is K4, right? And now we are only 3 lines are there, that is linking solenoids Y1 Y2. So K2 is connected to Y2 and K2 is connected to Y1 and Y3. So we'll take like this and one solenoid. So what I'll do, I'll just copy this 3 times because 3 solenoid valves are there. But here I want one more normally close. So this one is K2 and this one is Y1. And this one is K4. K4 is connected to Y2. That is for retraction. Y2 is for moving downward. And this one is Y3, where K3 is connected here. K3 and this is K2. Okay, so this completes circuit. So I want it in one screen. Let us okay. Now it is. I think it is linked all the circuits. So that means there should be a speed change, right? So what I'll do is uh, we'll have a simulation, but in this software there is some problem. That means if cylinder velocity is very high, so there is no detection of B1 and B2. Sensor detection is not there. So that is why you don't find the speed change. So I will reduce to speed to very low. Okay, let us see that when you operate S6, it goes with high speed, but there is no detection of sensor. There is a problem. So what I'll do is to reduce this cylinder speed by default. Actually, there is throttle valve is not in the circuit. Throttle valve is not mentioned in the circuit, but still I am taking it because it is demanding. Okay, so what I'll do is I'll go to the simulation. First reduce the speed of the cylinder because very high speed. Let us see this one and let us see whether detection of B1 is there, sensor is there or not. If you operate S6, still it is not detecting, reducing the speed. So now when sensor P1 is on, further speed is, see now it is very slow. It is log, it is called feed, or it is called the creep movement, or it is very slow movement of this cylinder. Assume that tool bit is attached. So tool is moving very slowly because it's a metal cutting operation is going on. I'll use little bit increase the speed and reset the button, then only you can start one more cycle. It is going with little high speed, but when it reaches B1, change it to very low speed. So to see the difference, what I can do is I'll close the throttle valve completely. Let us see what happens. So it should stop when it reaches B1. If you operate S6, yeah, it is stopping. See, it is stopping. So using throttle valve, I can decide the flow. So I'll just very slow speed. So it is moving actually, but very low speed. So to understand more, to support this simulation, I will add the laboratory video so that you can understand clearly what is the entire the circuit working. Okay. After this explanation, the next the part of the video will be the lab video. You can clearly understand the speed change from B1. So it is moving, it's moving, so it's taking a very long time. So let us little bit increase. So it is moving. Little bit will increase. So yeah, it is moving. When it reaches B2, it will retract automatically. Okay. Yeah. Thank you everyone. If you like this video, please subscribe to my channel, and don't forget to see the next part of the video. That is also important. That is a laboratory video. Thank you. In this video, we are going to demonstrate the hydraulic circuit, that is experiment number 5. The title is Rapid Advanced Circuit. That means in the hydraulic cylinder, this hydraulic cylinder is having a stroke of 20 centimeter or 200 mm. Sometimes in some applications, multiple speeds are required. Example, drilling machine sequence. Tool bit should approach the workpiece in faster pace, but when it is having a cutting operation, it should the speed of movement of the tool should be less, because otherwise the tool bit is going to break. So we are talking about feed given by the hydraulic cylinder. Spindle is driven by electrical motor, but feed can be given by the hydraulic cylinder. So what we are talking about is the entire stroke of the cylinder is 200 mm, but we are placing sensor B1 at certain distance, for example 100 mm, and B2 sensor placed at the 200 mm. So what is our requirement is a cylinder rod should reach at a rapid speed till B1. From B1 to B2, we are assuming that it is a drilling machine or a drilling. It's a drilling process. B1 to B2 is a drilling process. For example, metal cutting process. So speed of the movement should be very, very less. That we talk about like feed rate, right? So we should observe from B1 to B2 speed should be very less. So there are two speeds in a single cylinder. One is starting from the cylinder movement, high speed, but when it reaches B1, it should change from high speed to low speed. We are talking about feed speed. And when it reaches B2, cylinder should automatically go back with a rapid speed, so that total cycle time of the process will be less. Okay, so this is what the requirement. So now hydraulic circuit is designed here. So hydraulic cylinder, Movement is controlled by the 4x3 direction control valve here, which is operated by two solenoids. It's a 4x3 direction control valve. And to change the speed from high speed to low speed to high speed, we are using one more direction control valve, that is 4x2. Actually requirement is 3x2 direction control valve, but 3x2 is not there in the laboratory, so we are using 4x2 direction control valve. And this is a throttle check valve. This is a throttle check valve is used because we are controlling speed in only one direction. So another direction we are not controlling. So that is why we are using throttle check valve instead of only throttle valve. So this is a hydraulic circuit, and this circuit is powered by the hydraulic coil pressure from the hydraulic power pack that can be on and off. And the entire sequence is controlled by electrical control panel, that is relay circuits. This is a relay control panel, and this is having the distributor positive and negative portion is there. There is a distributor, electrical distributor, and switches, push button is there, toggle switches is there. But we have used three switches in this experiment, and relays we have used 4 relay, K1, K2, K3, K4. Still another 2 relays are there but not used in this experiment. So circuit diagram and hydraulic circuit diagram and relay circuit diagram are already shown in the diagram, so that can be displayed. So this is our already designed hydraulic circuit and electrical circuit. Now we'll show the working of this circuit. So we should observe there is a speed change from B1 to B2. Now by operating the start button here, is the start button. Operate the start button and you can see the change. It comes rapidly till B1. From B1 to B2 low speed. The return is high speed only. Now we have reset the circuit one more time. And speed can be adjusted using this throttle check valve. Have reduced further speed from B1 to B2. Yes, now it is very slowly moving. We should assume that metal cutting is going on. So that is a feed we are talking about. And this circuit is rigged up by the students with reference to the manual. So still it is moving very slowly. Once it reaches B2, that completes the process. So now when B2 is on, cylinder will go back automatically. And these are the students rigged up this hydraulic circuit and the electrical circuit. The students of final year SJCET Chikballapur, final year mechanical students. They are doing the 4 weeks of internship program.